The metal casing for the aluminum DVD plates consists of 2 aluminum plates made of rolled sheet metal that had been bent into shape. These metal plates are approximately 1/8 of an inch thick. The numerous features on the bottom plates have smooth contours, suggesting that they were punched into the plate. The other metal plates are 1/8 of an inch plate thick aluminum with the interior that has been stamped and a stamped copper heatsink. All these metal components are very thin, making sheet metal forming the most likely process. An alternative to bending the plates is machining or casting. However, the former is extremely expensive and the latter has a very high initial cost. Screws to hold the system together were very likely rolled. Rolled threading is stronger due to favorable grain flow and cold working stresses. Machining is an alternative, but is unlikely due to wasted material and the high production rate of rolled screws.
A printed circuit board is formed by a thin layer of conducting material deposited on the surface of an insulating board known as the substrate. Fiberglass is the most commonly used substrate material. The material passes through an oven where it is semi-cured, after which the material is cut into sheets. The panels are stacked in alternating layers of adhesive-backed copper foil. The stacks are placed in a press where they are compressed and heated to complete the final curing process. This also tightly bonds the copper foil to the surface of the substrate. The printed circuits themselves are made of copper, which is either plated or etched away on the surface of the substrate to leave the pattern desired. The circuit pattern is created by first pressing the photoresist material onto the copper foil and placing the pattern mask on top. The panel is exposed to ultraviolet light that irradiates the photoresist material. With the mask removed, the surface is then sprayed with an alkaline developer that dissolves the photoresist layer and exposes the copper foil. The panel is then electroplated with copper. A tin lead coating is applied over the copper plating for protection from oxidation. With the final pattern laid out, a solvent is applied that dissolves the remaining photoresist layer, exposing the copper layer. The excess copper not forming circuit patterns is dissolved with an acid wash. Board components are then placed, such as resistors, capacitors, or integrated circuits, and soldered in place. Components on a printed circuit board are electrically connected to circuits by 2 different methods. With through-hole method, each component has thin wires pushed through holes in the substrate soldered to connection pads on the opposite side, such as the case with the larger printed circuit board and our DVD player. With the surface mount method, legs on each component contact the printed circuits directly. The smaller PCB holding the main integrated circuits is constructed by surface mounts. Components are connected using wave or reflow soldering techniques depending on mounting method. Manufacturing processes used in making the 3 printed circuit board components include photolithography to create the initial circuit pattern and an etching process to make the final circuit. Holes are drilled after the substrate is hardened, but before circuit layout.
The plastic components of the DVD player are made from thermoplastic material, which can be molded at a high specific temperature range and solidify when cooled. This is a function of the plastic's material characteristics and the machine mold combination. The complex shape of the plastic design are achieved by the injection molding process. The process starts out with plastic pellets stored in the hopper. They are then deposited into a large long screw where the plastic is melted and conveyed forward. When enough plastic is melted, the screw pushes it forward and it flows through the many channels of the molding machine, starting from the injection barrel, nozzle, sprue, runners, gates, and onto the mold cavities. When the mold is nearly full, the speed control ends and shifts to pressure control. The process forces additional plastic onto the mold, known as the packing phase. When the part is cooling enough, the mold opens to release the part and the cycle starts over.